Okay, we're back with another problem in the calculator section that a calculator is completely useless for. Um, so this gives us a shaded region or a region area under a curve where they ask if a left Riemann sum, a right Riemann sum, and a trapezoidal Riemann sum are used to approximate the value of the area under this curve, which is represented by this integral right here, each using the same subintervals, which gives an underestimate. So what I would do here is I would actually make basically something really simple, and I would almost make points and actually do the rectangle. So with left rectangles, you're going to use the leftmost point, and you can see right in this area here, there's underestimates. And that's with a left point. So we're using the left point on each of those. That point, that point, that point. You can't actually see this rectangle, but that point. Okay, so we have a left Riemann sum is an underestimate. Okay, so this is true. Now if you were to go and use a right Riemann sum, we'd be using the right point for all of these, and you'd see we'd have overestimates. When you're doing the actual problem, you wouldn't necessarily do both. If the left is an under, you can assume that the right is an over. So it's not that one. Now the tricky one is the trapezoidal. And you're sort of inclined to think, well, maybe the trapezoidal just sort of fits it perfectly, but let's actually quickly sketch this one out. If I take a trapezoidal, because of the concavity of this shape, I'm going to pick points, and you can imagine that if something is concave down like this is, picking 2 points and having a trapezoid like that, well, we're still going to have this underestimate like that. So trapezoidal is actually also true, and this one matters with the concavity. You can picture if it was concave up, the trapezoidal approximation would be an overestimate, as you can see here. It's a little tricky on the graph that they give us because the concavity isn't that pronounced. If you notice, I did ones that were kind of exaggerated, and it was easier for me to see. So statement 1 is correct, statement 3 is correct, so answer choice D is correct. This is something similar to a lot of the topics on the AP exam where you kind of learn one concept, you understand it, you spend some time, and you get 1 point based on this. This type of problem is not going to show up 15 times. This is not the fundamental theorem. This is not the concept of integration, learning how to correctly take an integral. This is sort of a little thing that will give you a point, maybe 2 points, if it shows up on a free response. But you add a point here, and you add a point there, and you learn all these topics, and all of a sudden you've got a 5 on the AP Calculus test. Alright, I would play this one back if you don't understand it, and I'll see you guys back for problem 81.